Welcome back as we continue with our differentiation rules, our little calculus section here. So previously we've talked about using power rule, where we had polynomials. Now we're going to be looking at product rule. So product being the answer to a multiplication problem, we're going to see how this comes into play. So if you ever say the word multiplied or times in these derivative problems, you must use this product rule. Basically, if there's two or more terms being multiplied together, and we'll see what that means in a second. Now, the actual product rule itself is as follows. So if they give us a two-piece something or other, so if it's like f times g, and we're trying to find the derivative of this, remember that little tick mark means derivative? That means take the derivative of the first part and multiply it to the original g, and then add that to the original f times the derivative of g. So a little way to break this down here, and I'll box this for us. That is the product rule. So derivative of first times the second, and then the first term times the derivative of the second. Alright, so kind of sloppy there, but we'll see how this comes into play in a second. So first problem, so find the derivative. Alright, so the actual equation, f of x equals x plus 3 times x squared plus 5x plus 2. And you'll hear right there, we said times. So what that means is, this piece right here is the first piece, this is the second piece, and they're connected by multiplication. So in terms of the product rule, let's name these f and g. Okay? So the first part is f, the second part is g. What we want to do is follow this pattern here. Derivative of the first one, f, times g, plus regular f times derivative of g, the second part. So let's follow this out. So I'll write it over here. We want f prime g plus, multiplied, plus f times g prime. Okay? So let's go down the row. Let's take f prime, so the derivative of f. So we're finding the derivative of this whole thing. So the derivative of the first part, that's x plus 3. The derivative of that is just going to be 1, because remember the x gets derived to 1, the 3 gets derived to 0, so that's just a 1 there. We're going to multiply it to regular g, so don't change g, just write it. X squared plus 5x plus 2 plus. Alright, now take regular f, this one here, take regular f, x plus 3, and multiply it by the derivative of g. So now let's take the derivative of g. So the first term, that's 2x. The next term, plus 5. The last term, constant, becomes 0, so we can close this. So there's all my pieces there. And if you want to relabel it, well, I'll relabel it for you guys. This is derivative of f, this is g, this is f, and this is the derivative of g. And there's all that we had right here. That's what we needed to do. And now we're going to multiply this out, simplify it, and just make it look a whole lot better now. So 1 times all those terms doesn't really change anything. So we got x squared plus 5x plus 2 plus, now we got to multiply this out. We FOIL it, or you can do the box method. I've already got it in parentheses, so I'm going to FOIL it out. So x times 2x is 2x squared plus 5x plus 6x plus 15. Now we've got lots and lots of terms. So let's go ahead and simplify. Biggest exponent is x squared. I've got x squared and 2x squared, so that's a 3x squared. Cross them out when you use them. 5x, 6x, that's a 16x. And finally, a 2 and a 15 makes a 17. So the derivative of that original function, 3x squared plus 16x plus 17. So we had to take the derivatives of multiple pieces and then some of the regular ones. All right, let's see another one. Differentiate. And remember, that just means find the derivative. Okay, so y equals 2x cubed plus 1 times 5x to the fourth. Okay, and again, I said the word times or multiply, so that means we have to use product rule, and product rule is f prime times g plus f times g prime. F is the first part, g is the second part. So let's find the derivative of this. So first one, it says take the derivative of f. So derivative of f would be, we carry this down, so 6x, and then that comes down by 1 squared. Plus 1 becomes a 0, so let's close that. I need to multiply it with just regular g, and that's regular g right there, so 5x to the fourth. Plus, take regular f, 2x cubed plus 1. Multiply it by the derivative of g. So the derivative of g, 5 times 4 is 20, x, 1 lower, to the third power. Let's multiply stuff out. 6x squared times 5x to the fourth is a 30x, and we add those exponents to the sixth. Plus, we got to distribute here, 40x to the sixth plus 20x cubed. We do have a little bit of like term going on. It's the first two. 30x to the 6th and 40x to the 6th makes 70x to the 6th plus 20x cubed, and there we go. That is the derivative using product rule. Okay, let's take a look at a couple of trig functions now. So we're still going to use product rule, but now with some trig functions. So for example, let's say they give us y equals 5x squared times cosecant x. And again, I said times right there. That means we need to use product rule. Product rule is f prime times g plus, whoops, getting it backwards, f times g prime. This one here is f, this one here is g, so let's follow the patterns. So y prime, finding the derivative. So I need to find the derivative of f, so that's going to be 5 times 2 is 10, x to the 1 lower, so x to the 1, times it by g. G is just cosecant x, plus regular f, so 5x squared, times the derivative of g. So now we got a trig function here. We need to find the derivative of cosecant. And if we look back to that lesson, the derivative of cosecant is cosecant x, cotangent x. Let's clean it up a little bit. So y prime equals, now really all we can do is just drop those parentheses. Oh, I made a mistake, I apologize. The derivative of cosecant is negative cosecant cotangent. Okay, don't forget that negative sign right there. All right, so all we really do now is drop the parentheses. We've got 10x cosecant x. This one's going to become a minus because of this minus sign here. 5x squared cosecant x cotangent x. All right, and there's our answer. One last trig function. So y equals cotangent x, tangent x. Now this is still a product rule. We didn't really say it, but these are connected by multiplication. Oops, multiplication. You guys get the idea. Oops. Multiplication. So we've got to do, again, f prime times g plus f times g prime. This time both f and g are trig functions. So y prime equals, so let's find the derivative of f. Derivative of f, so the derivative of cotangent is negative cosecant squared. I'm going to multiply that to regular g, and g is just tangent of x, plus f, that's cotangent x. And then taking the derivative of g, derivative of tangent is secant squared x. And there's really not much to do on this one, rather than get rid of the parentheses, so it's negative cosecant squared x times tangent x plus cotangent x secant squared x. Alright, so we're mixing and matching some derivative rules. We've got polynomials, we've got trig functions, but we're still going back to our original derivative rules with the addition of this product rule here. Remember, f prime times g plus f times g prime.